This next one looks like we have all sorts of stuff going on, which is good. We have our h value here in the form of -2 because it's x minus h. We have our k value in the form of 5. And we have an a value in the form of -2/3. So what's going on here? Well, first we could probably speculate that our vertex is at -2, 5. -2, +5. We know the a value is negative, so I think that means it's going to go down, but down at a multiple of 2/3. So thinking about that, our jump pattern would be down, it's a negative, it's not plus, it's down 2/3, down, well, let's show the multiples. So +1 times -2/3, +3 times -2/3, +5 times -2/3. So when we compute that, that becomes -2/3, and the next one would be -2, and then the next one after that would be -10/3. So let's use that. And remember, I could go down, so I go over 1 down 2/3, over 1 down 2/3, and then over 1 more down 2, 1, 2. Kind of a difficult jump pattern to show precisely. And then over 1 down 10/3, which is 3 1/3, so third, 1, 2, 3, the third, 1, 2, 3. And that's enough points to graph it. We generally make sure we label our points. Something I didn't emphasize before, but very important to know which points you have. So I certainly have that point. These are relatively easy points. Name 1 and 1, -1, -1. And then I had another point in here, which was -1, comma, and then 2/3 less than 5, which is 4 1/3. And this point right here would be -3, 4 1/3. So generally I'll ask for 5 points, sometimes 7, but those are sufficient to then say you know the pattern. Again, I can test these. Let's test 1, -1. -2/3, 1 plus 2 squared plus 5. So this is -6 plus 5, which is 1. -1, sorry, -1. So that works. So again, my notion continues. My line of symmetry, oh, now I have some questions to answer. My line of symmetry, x equals -2. Excellent. My vertex is at -2, 5. And I know that my a value is -2/3, which means it's flipped and fatter than x squared, than y equals x squared. So these are sort of the characteristics of this function.